Welcome to Earth Science, everybody. Next in our quest to get through all of the meteorology reference tables is this bad boy right here, which you can find on page 14. This is not one of the easier ones, but not the hardest. This is somewhere in the middle, a medium level difficulty reference table. What it covers is the surface winds that we have on Earth, the prevailing winds, the general large patterns of winds. Does this mean every single day in these belts it's exactly like that? No. As weather systems move around, they can move counter to this. But the way that the major weather systems move, the way that your overall average winds are going to be, this determines that. Well, it doesn't determine it. It already exists. It delineates that. It shows us that. It demonstrates that, right? Here's one just from a random website that I think is just a tiny bit better because it's in 3D, although they have way more information than we need. It lets you see that on the outside here, that's the atmosphere. And in the atmosphere, there's these big convection cells. In fact, we could be even more specific. We could say it's the troposphere. In the troposphere, there's these big cells that move around, and that results in these winds being on the surface. This one, a little bit more flatter and two dimensional, but it kind of works. The dotted line around the outside should be the, yeah, it says it right there, is the tropopause. Let's make this a little bigger too. Too big. The dotted line outside, around the outside is the tropopause. So this like ring right here is the troposphere, the layer of the atmosphere we live in. And then this circle will be the Earth, and then these lines would show the prevailing winds on Earth. By latitude, they throw 0 on there, 30, 60, and then we can kind of assume that the pole is up there at the top, so we don't need that dot. It's important to know where we live, and if you forget, you can go back to other reference tables, right? I even have one open. You could go to this guy and approximately figure it out. You could go to this guy and approximately figure it out. We're in the Great Lakes here in the mid 40s, north latitude. So that puts us somewhere between 30 and 60. In other words, we live in.
All the buses have arrived. You may be dismissed. All the buses have arrived. You may be dismissed.
Sorry about that, everybody. That puts us in about this wind belt right here, the prevailing southwesterlies, sometimes they'll call them. If there's ever a question asking what the name of it is, just copy it right off here. People will get like say, oh, these are the trade winds, these are the prevailing southwesterlies. Don't panic about all that. Just use the reference table. It will never be wrong. All right. So our winds and our weather tends to come out of the west and move its way eastward. If you watch pressure systems, and when we get into meteorology, we'll do that. We'll see them moving across the country from west towards the east. And that's maybe why this reference table is a touch harder because it kind of moves into some of the stuff we have not done yet. So keeping it simple, just to get an acquaintance with this thing, that's our goal. What do we got here? Let's look, and here's how easy some of these questions are going to be. At 0 degrees, it's wet. I don't know if you want to highlight these or not. At 30 degrees, it's dry. At 60 degrees again, it tends to be wet. Now, the why on that gets a little complicated, and again, we'll get into that. What I stole over here, if you can make heads or tails of this, this is take a world map, and what they did was they only put on rainforests and deserts. So if I like this because the equator, according to this reference table, the equator should be wet, and we will get into why that's the case. But if you look near the equator, which runs right about through here, that line's way too big, but right about through there, that's the equator. And what do we got? We've got the Amazon basin, rainforests, Congo, rainforests, Southeast Asian islands through Indonesia, Papua New Guinea, all of these guys, all rainforests, right? That is Earth's major rainforest belt right through there. And then what about at 30 north? Well, 30 north, you got the Southwest United States, North Africa, the Middle East, some of these areas up through Southern Asia, all desert like. Or 30 south, you can get more and more and more deserts. So the real life matches up with this thing reasonably well. Not a ton that we really, again, at this point, that we really need to get out of it. Identify which direction the prevailing winds. Note they're always named for where they come from, just like we always talk about low winds. Tell me which latitudes are wet, which latitudes are dry. Maybe we'll get into a little bit of the idea that there's convection happening here in the troposphere, but there's some of that we're definitely saving for the next chunk of class. Um, Certainly, what we want to notice is that here in the northern hemisphere, all of the arrows bend a very specific way. It's easy to see this one bending to the right, and you will have people argue that this one's actually bending to the left, but it's not. I don't know if I can flip this over in Cami or not. Do we have a flip? I don't know. Turn your head upside down, turn your computer screen around, and you'll see that this arrow actually is bending towards the right. They're all bending towards the right. Here in the northern hemisphere, these large scale patterns, like we talked about with ocean currents, all these major prevailing winds bend to the right. Whereas in the southern hemisphere, it's easy to see that one bending to the left and that one bending to the left. Trust me, if you can flip this paper upside down, that one is also bending to the left. So in the southern hemisphere, all of these major global winds bend to the left. And the reason for both of those, which is definitely a thing we're going to want to know, put my pen back to normal here. The reason for both of those things that bend is the Coriolis force. I'm actually going to go Coriolis effect caused by Earth's rotation. Since the Earth is spinning, these winds that are traveling in these straight lines bend. There's always going to be more to unpack with that. We're not done with Coriolis effect, but we're just starting to nip around the edges of it. All right. Now, a cool thing that happens. This video right here kind of demonstrates it. What this is 20 years worth of data um, going pretty fast here. You can see the seasons. That'd be we're going into summer in the northern hemisphere and then winter in the northern hemisphere. So they're whipping through the years reasonably quickly here. What you can see, especially in Africa, you can see that where there's a lot going on moves up and down with the seasons. And you can see it a bit in the other places too. India is a place where this has a giant effect. What your reference table actually says for this, and I snipped it out just to save some space on the notes, is that this drawing over here is around the time of the equinoxes. If we're really comfortable with seasons, which I would hope we are at this point, we would know that the Earth is kind of tilted towards the sun for our summer and then tilted away. And it's not that it flops back and forth, it's that it's in a different position around the sun throughout the course of the year. But what that does to all these wind belts is it moves them up and down with it because these all really depend on the sun. Like the direct sunlight hits here, that's where it's hottest, that's where air is rising up off the surface. But if you tilt the Earth back, the sun is still then hitting right there. That line will creep down, and then you tilt it forward, and it will creep back up. So, like what you see here, this back and forth motion through the seasons is really a back and forth motion of those wind belts as they move their way up and down. The regions very, 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 very rarely picks up on that. But it's kind of a neat thing. And it does lead to a situation where, depending on where you live on Earth, we live in like right about the middle of this one. So if it like tilts up a bit in the summer and comes down a bit in the winter, it doesn't really have a huge effect on us. We still kind of live towards the middle of it. But what if you lived in an area where either the wet or the dry kind of crept over you? And the like the type section, the most typical area for that where this is mentioned is India. India has about half a year where because of this shift, they've got air coming down from the mountains that's very dry. And then the other half of the year, because of the shift, they've got air coming off the oceans that's very wet. So they have a very dry season and a very rainy season, which is the definition of a monsoon. This is a seasonal shift in wind direction. Now it's associated with a lot of rain because when the monsoon comes, when the wind direction shifts so that they're getting it off the ocean, they get a lot of rain. But you'll see this term misused a lot. It'll be rainy as can be outside, and somebody will say, well, it's like a monsoon out there. And that's not quite accurate because a monsoon is the shift in wind direction that, yes, that can create rain, but we're not experiencing that in upstate New York. We don't have that. We don't have a seasonal shift in wind directions. So that's like being a picky earth science teacher, right? But keep in mind that the monsoon is the wind thing, not necessarily a rainstorm. Rainstorms are a separate idea from that. All right. What do you think? Maybe the questions here will be a touch harder, but I'll stick to on the classwork having there only be ones that like directly deal with what's on this table. When we get into real meteorology coming up soon, we're going to have to deal with okay the idea of rising air. We're going to have to deal with the idea of these jet streams, these subtropical jet streams separating out the wind belts and how they can move and flow and morph a little bit. I'm going to go to one more website here. I'm going to pause to find it and let's check out one cool thing and then we'll wrap it up. So, as I mentioned, weather systems themselves can like work against this and they can make it so that it doesn't work. But if you erase all of those, if you're in an area without many weather systems, you can see that it follows pretty well. So here we are near the equator. Let's check out the reference table again, where we should have southeast winds and northeast winds converging towards the equator. And we got it. These winds right here, these winds right here are converging. All right, now, again, pressure systems can kind of make these things go awry a little bit. Let's see, towards the 30 should be, yeah, it's not showing up great today because we've got some pretty strong weather systems that just blew through, which is why it's been so crazy this last week. But we'll see how these systems come out of the west and work their way east once you're on this side of 30 degrees because they're following that wind pattern and moving their way as they go across. All right. Earth.nullschool.net, kind of a neat website to check out all these global wind patterns. See what you think. All right. We'll call it good there. Try the classwork, see how it goes. Good luck, everybody.